What's up, everybody? Patrick here, moving on to another question. This question is fairly tricky. There's some subtle things you got to be aware of. So you got to sketch and state the equation of a fourth degree polynomial function with n behavior as x approaches negative infinity, y approaches positive infinity, and there are three zeros, three x-intercepts at f of 3 equals 0, f of negative 2 equals 0, and f of negative 5 is equal to 0. So what I suggest we do is I say we just draw out the information that they have given us so far. So let's start with this n behavior here. So as x approaches negative infinity, y is going to approach positive infinity. So we know that the left side of the function is going to look like this. And then there are three x-intercepts. So f of 3 equals 0. So that's going to be, let's say like right there. So that's going to be 3. F of negative 2 equals 0, so at an x value of negative 2, the y value is 0. And then f of negative 5 is equal to 0. Let's say that's like down here. So this is negative 5 there. Actually, let's write it here just to be consistent. Okay, so we have this n behavior, and we have three x-intercepts. Now, what's the other n behavior on the right side going to be? Is it going to be down here, or is it going to be up here? Well, if you read carefully, it says it's a fourth degree polynomial, meaning it's an even degree polynomial, so it's not going to have opposite n behaviors. That would be an odd degree polynomial. So we know that this won't work, so we know that this function on the right side, it has to have this n behavior right here. And it's a fourth degree polynomial. Now, if you remember, even degree polynomials, if they have a degree of n, they can have at maximum n intercepts. So it could potentially have 4 x-intercepts. But notice that this one only has 3 x-intercepts, meaning that at one of these x-intercepts, there's going to have to be some kind of bounce. So it doesn't matter which one you pick that has the bounce, but at one of them, there will have to be a bounce. Because if there isn't, if I don't bounce it off one of the x-intercepts, what's going to happen is that that n behavior is not going to match what we're trying to do here. So maybe at this 3 here, I could bounce that function off and make it look like that. So whenever a fourth degree polynomial or any even degree polynomial has an odd number of x-intercepts, then there's always going to be some kind of bounce at one of the x-intercepts. So notice this is a degree of 4, and there are 3 x-intercepts, an odd amount of x-intercepts. There has to be a bounce somewhere. Now, it doesn't necessarily have to be at the 3 here. It can also be, we can like redraw this. So let's, you can also have the bounce, let's say at this negative 5 here. So it could bounce at negative 5, go through negative 2, like that. Or it can go through, let's say it can go through negative 5, and it could also bounce at negative 2. So it could look something like that, right? So you have a bunch of options. And notice that no matter which x-intercept you bounce this function off, it's still going to keep the characteristics that we were given. That n behavior is still going to stay the same. The x-intercepts are still going to be there, and it's only going to be those 3. And the proper right n behavior is going to still be there because it's a fourth degree polynomial function. So it's going from quadrant 2 to quadrant 1. So it doesn't matter which ones you bounce it off, as long as there is a bounce somewhere there, then you're good. And then we also have to state an equation. So again, a bunch of options for the equation. So let's start off making the brackets, the factors, depending on these x-intercepts. So we'd have x plus 5 here. We'd have x plus 2. And then x minus 3. And again, notice how this here has a degree of 3. We need it to have a degree of 4, so we have to add a squared on one of these factors. And it depends on which x-intercept we bounced it off. So in this diagram, we bounced it off the -2 x-intercept, so this x plus 2 will be squared. But again, you can have the x plus 5 squared, and it would be the diagram before when we bounced it off the -5, or you can have the x minus 3 squared, meaning that it's going to bounce off that x-intercept of +3. But this diagram here follows this equation. We're bouncing the function off -2, so the x plus 2 is going to be squared. And then you can also, if you want, you can add like any a value here, so that's just going to make the function, it's going to stretch it or compress it, so you can have like a 5 here, you can have a decimal even, whatever you want. I'm just going to keep it as 1, so I'm not going to write anything. But that a value is not going to affect these characteristics that we were given. Still going to have that end behavior, still going to bounce at that -2, and it's still going to have the other x-intercepts of -5 and 3. So a bunch of different options for this question, a bunch of different options for the sketch and the equation. The important thing to know is that we were given the left end behavior. It's a 4th degree polynomial, so the right end behavior is going to be in the first quadrant. And because we were only given 3 x-intercepts and it's a 4th degree polynomial, at one of the x-intercepts there's going to have to be a bounce.